Hello my dear students, I hope you all watched the previous chapter, Physical World, done by Sir. So what all things you have seen there? You have seen some basic idea about physics, right? You might have learned some of the basic phenomena, what you see in physics and the fundamental forces. Yes, you have seen the 4 fundamental forces in nature. Then you have also learned why you need to learn physics, the scope of physics and the laws of physics. Okay. So we will continue further. We will move on to the second chapter, that is units and measurements. So why we need to study this chapter? Okay. The simple example I can give. So if your mom sends you to shop and tells you to buy some rice. Okay. So when you go there, what kind of communication you are going to have with the shopkeeper? Will you say like I need 2 rice or 3 rice? No, right? You need to mention something at the end of the numerical, correct, right? The quantity, when a number becomes quantity, when it has a unit with it, correct? So when you go to the shop, you will say that I need 2 kg of rice, or if you want some other quantity things, you will say everything with a unit along with the numerical number. Okay. So what is this unit and why we need to learn that? The basic definition you can see, measurement of any physical quantity involves comparison with a certain basic, arbitrary chosen, internationally accepted reference standard, that is called unit. Okay. So it should be internationally accepted. It should be everywhere the same thing. So when you go and buy some 2 kg of rice in India, the same 2 kg of rice you should get when you go to some other countries also. Correct, right? So it should be internationally accepted unit. Okay. So fundamental unit and derived unit. These are the 2 types of unit which are related to the fundamental quantity and the derived quantity. Okay. So I'll explain what is this fundamental quantity. Fundamental quantity is also called as base quantity. So we have mainly the things which we come across: mass, length and time. So these are the basic quantities we come across most often. And derived quantities are the quantities derived using this fundamental quantity. So I'll give you some example for derived quantity, you can understand it. So derived quantity may be velocity. So you people have studied in your high school, right? Velocity. How do you write velocity? Velocity is meter per second, correct, right? So do you see here meter? Meter is nothing but unit of length, right? You see time, correct? So second is a unit of time. So I'll give one more example so that it will be easy for you. So I can get one more example, maybe acceleration or something related to any other quantity. Okay, acceleration if I write. So it is meter per second square. You see here, meter comes with the square of time, correct, right? So this is what we understand. The fundamental quantities are the basic quantities and unit related to that is known as fundamental unit. So for mass we have kg, okay. Then for length we have meter, then time we have second. These are the fundamental quantities. When you derive the quantities, you can have all the units which will be related to this fundamental quantity. A unit which will have a connection with the fundamental quantity. Now, what we call the system of units. System of unit should contain both fundamental unit as well as derived unit. System of unit, it's a combination of fundamental units and the derived units. They are together called system of units. Now, what is the condition why this unit will be accepted? Where this unit will be accepted? So it should be internationally accepted. Now we have some international system of units. So these are the things: CGS system, FPS system and MKS system. So these were the unit which were used earlier. Like this is usually used by British people. Okay, it is a popular units were used in Britain. So that may be the reason why you will see some of the British calculations will involve this one. But now it has been replaced. CGS system was the first one which is C stands for centimeter, G stands for gram, and S stands for second. Similarly, FPS system, F stands for foot, then P stands for pound, and S stands for second. But this one, MK system, which is actually accepted internationally for the time being. The system what we are usually referring is the MK system. So MK system deals with the M for meter, K for kilogram, S for second. Okay. When this will be accepted internationally. So the internationally accepted units are known to be SI units. Okay. The abbreviation SI unit is for internationally accepted unit. So that's what I told earlier. Even when you go to some other country, there also the unit what you are using for length will be meter. At the same time for mass it will be kilogram, and time will be measured in second everywhere. So that is how it is internationally accepted. Okay. Now let me explain you some of the basic quantities and their SI units. Okay. So length SI unit is meter, denoted by small letter m. Mass, it is kilogram, denoted by small letter kg. Time, seconds, denoted by small letter s. So these things we have already seen. Other than that, there are 4 more fundamental quantities. Okay, they are electric current. Ampere is a unit of that. Thermodynamic temperature, it is a Kelvin temperature. Right? So 0 degree temperature, it will be known to be like 273 Kelvin, or you have the 0 Kelvin, that is a absolute temperature, minus 273 degrees Celsius. Okay, it is the smallest temperature what you can obtain in this universe. Now, amount of substance is known to be mole. Okay, and it is denoted by MOL, small letter. Then one more thing, it is about luminous intensity, it is candela. Okay. So these are the basic quantity and their fundamental units. So 7 are the basic units which you need to be familiar with. Okay. Now we will move further. We need to focus some more quantities which are dimensionless. Dimensionless means they don't have any unit. They don't have unit. So the first one comes here is a plane angle. So we have not mentioned angle over here, right? So that's the reason why we have 2 more fundamental quantities, that is, one is plane angle, another one is solid angle. So these are the very basic things. Okay. So plane angle, right, when you can have 2 sides. Okay, so this is a plane angle, so this is 0 degree, and if I go on increase this one, angle will go on increase. So now you can see it is 90 degree. As it goes on increases, okay, you can have 180 degree. If you comes one rotation, you will get 180 degree. So angle with respect to a particular plane is known to be a plane angle. Okay, so see, I have a plane over here and I have an angle with respect to this plane is known to be plane angle. So how do I calculate this plane angle? I can calculate using very simple formula. Okay, that is d theta, that is equal to ds divided by r. So ds is nothing but arc length. Okay, ds is arc length, and r is a radius from the center to a particular point where you are going to measure it. Then theta is a angle. Okay, so this theta will be measured in radians and is usually denoted by small letter RAD, or we call it as rad. Okay. Next one is about solid angle. So I can say the definition of the solid angle. It is an angle subtended by the surface at the center of the sphere. So if you take a watermelon and you just make a cone shaped hole into it, then each time when you come towards the surface, you will get a certain circles, right? So this circle is a kind of angle made by the surface with respect to the center, and that is known to be the solid angle. So you can see here, I can get everywhere, I can get this angles. Okay, angle subtended by the surface at the center of the sphere, that is known as the solid angle. So you will come across this in the next coming topic, so you will get the clear idea of that. Okay, So I can write the equation for that. Equation can be written as d omega, that is nothing but dA divided by r square. So dA is nothing but area of this surface, r radius square of that. So equation will be d omega is equal to dA divided by r square. It is measured in terms of steradian. So here you have seen angle was radian. The solid angle is measured in terms of steradian and it is denoted by SR. Okay. So both these quantities, plane angle and the solid angle, they are dimensionless. Okay. They don't have any dimension. You can see here. So if I say like this is arc length, right? Meter will get cancelled with the meter on the denominator. Similarly, area meter square will get cancelled with the meter square on the denominator. So solid angle as well as plane angle, they don't have any particular dimension. Okay, they are dimensionless quantity, even though we call it with some units. You can refer to appendices given on 203 page number of your NCERT textbook. If you check with your textbook, you can see so many appendices are given. In that you can get the basic ideas of all the things what you study in your physics this year. Okay. So about the Greek alphabets, then symbols used to refer different quantities. Okay. Then you have some important constants and their values. Then also you have many ideas related to the topics what you are going to discuss. Then some of the standard units, all those things. So you can start from page number 203 on your NCERT textbook. Just go through that and be familiar with the things. Okay. So how do you measure length? Okay, measure of length we will see. Usually when you are given with a small quantity of measuring this one. Okay, I'll tell you to measure the length of this. You can use your centimeter scale. Correct, right? You will go for centimeter scale and you will find the value of that. If I give you this one, again you can go with the centimeter scale. You can find the value. If I tell you to find the length of this hall or your classroom, you can again use the meter scale. So you are changing the value, correct, right? You are going to meter. Then if I tell you to measure the distance from your home to your college, so you will have to go for kilometer. You can measure it. How? Maybe the speedometer of your vehicle will measure the distance. Again, if I tell you to measure the distance from India to some other country, again you can measure the distance. But if you want to measure some distance that is from our planet to another planet, how do you go for that? So is it so easy? Can you measure it with the kilometer length? No, right? So we are going to use a particular kind of method for that. Okay. So large distance will be measured using parallax method. It's a very simple method. Okay. For the understanding of simple parallax, I can give you an example. So when you point a pencil on a particular point on the wall, okay, you close your one of the eyes and just look that, or you can close your left eye, just look at that point. Without changing the point, you just close your right eye, open the left eye. Then you can see that there is a shift in the position. Don't you observe that? You can just check it. Okay. So when you point on a particular position or anything, object with your pencil, then you close one eye, see with another one, then just do the vice versa. Then you will see there is a shift in the position. So the same thing, okay, the method where we get the shift in the position of the object is known to be parallax method. Okay, we will see the definition, what it says. The effect where by position or direction of an object appears to differ when viewed from different positions. Okay. How this method is used to find the distance from Earth to any planet or star something. We will see that. So let me take S as a distance source. You can take it as your planet, any planet or sun or any star, anything you can consider. Then I have 2 points over here, A and B. Okay. So let me have this in one place, point A, and B somewhere else. And one condition that I should know, that I should know what is the value of B. Okay. So this B has to be known. By knowing the value of B and knowing the value of theta. So theta is nothing but angle between these two particular points to a fixed object. So knowing the value of theta and B, you can find out D. So D can be calculated. You know one thing, okay, this theta is nothing but parallax angle, AB is known to be basis, okay. Then you know one thing, you just see this B and D. D is a very large distance compared to B. So when I take the ratio, okay, B by D, you will get a value which is very small. Correct, right? Why? See, B is very small. It may be the distance between two places where you are observing. So you observe from this place, then you also observe from this place to the common object. So A, distance between A and B is very small compared to the distance what you are measuring. Correct? Okay. So having B by D is very small, you will have this angle very small. Obviously theta has to be very small. Then you can have a formula which this can be related to the same thing what you have seen here. Okay. I can write D is equal to B by theta, or if you want you can write theta is equal to B by D also. So this method is known to be parallax method, which will be used to find the large distance. Okay. And also this method will be effective in finding the angular size of a planet. So angular size of the planet means the diameter of the planet can also be measured. So you can see this. With a single telescope, you can focus first one side of the planet. Okay. So then again from the same point you will focus on the other side of the planet. Then what do you get? You can get the value of B. You can get the value of B when you have the formula alpha is equal to D by, this must be B by D. Same thing, whatever you have used here, same method you will be using here. By knowing the value of alpha, you can find out B. So I can write B will be equal to alpha into D. Okay. So this method is an effective method in finding large distances as well as the size of the planets. Okay.